Hello students, in this video we'll see an example of finding the tangent plane to a surface. Consider the surface z is equal to x over y plus 2y minus x cubed. Let's find the equation of the tangent plane to the surface at the point 1, 2. There might be a little bit of an issue in y is equal to 0, but since we're at the point 1, 2, it won't matter for our problem. So let's recall what the equation of the tangent plane is. So recall that z minus f of x0, y0 is equal to fx at x0, y0, x minus x0 plus fy at x0, y0, y minus 0 is the equation of the tangent plane. So this z variable will define a plane. So z here will define a plane. Is a plane is the tangent plane. Okay, so let's do it. So I need x derivatives and y derivatives in the point in question. So first of all, the point in question, if I plug in 1 to the function, what will we get? The function f of xy is going to be x over y plus 2y minus x cubed. And so f of 1, 2, for example, the point we're given, is going to be a 1/2, 1 over 2, and then 2 times y, so 2 times 2 is going to be a 4, and I'm going to subtract 1, because 1 cubed is that. So I'm going to have a 3 plus a half, so that's going to be 7/2. So 7/2 is the value of our function. Let's next compute the x derivative. The x derivative of this function is going to be, the x derivative of x over y is 1 over y. The x derivative of 2y is 0. And the x derivative of x cubed is 3x squared. So if I plug in the point 1, 2 into my x derivative, what will we get? Well, y is equal to 2, so this is going to be a 1/2 minus 3. 1/2 minus 3 is going to be negative 5/2. So that's my x derivative. Next, let's do the y derivative. So my y derivative, fy, the y derivative of x times y, well, that's really x times y to the negative 1. So that's going to be negative x over y squared. And then the y derivative of 2y is just going to be a plus 2. The y derivative of x cubed is 0, so that's my fy. And so fy at 1, 2 is going to be negative 1 over 4, negative 1 over 4, and then plus 2. So that's going to be negative 7. That's going to be positive 7 over 4. Now we can fill into our tangent plane. So the equation of our tangent plane, our z for our tangent plane, is going to be the value of the function at x at 1, 2, which is going to be 7/2. That's the value of my function. I'll throw it on the other side. And then what? And then minus 5/2. X minus x0. The x0 here is 1, so x minus 1. And then plus 7/4, that's the y derivative, and then we have a y minus y0. The y0 here is 2. And this is the equation of our tangent plane. We can actually see what the normal vector of this tangent plane is. It looks like the normal vector to this tangent plane is going to be what? It's going to be negative 5/2 and then 7/4. And if I throw the z on the other side, I'll get a negative 1 for the z coefficient. Thank you very much.